Hello calculus students, we're here doing section 10.11, finding Taylor polynomial approximations of functions. So in this problem we have the function natural log of 4 minus x, and we're trying to write the third degree Taylor polynomial for this function centered at 3. So what we need to recall is that the equation for a Taylor polynomial in general is f of a, or the function value at the center, plus the first derivative at a times quantity x minus a. Continuing our pattern here, we have then plus f double prime at a times x minus a squared over 2 factorial. And then finally our last piece, since we're going to be only doing a third degree, we only need one more piece, and we're going to have f triple prime at a times x minus a to the third power over 3 factorial. So in our problem, we need to take multiple derivatives of the function natural log of 4 minus x. We also need to evaluate it exactly at 3 for the first part of the actual Taylor polynomial. So natural log of 4 minus 3, or the natural log of 1, would be 0. So this term here would be 0. In all the other cases, the a's are going to be replaced with the number 3. So I could take those out now, I guess, and put a 3 in for all their... Let's take that a out. And we could put the number 3 in. So we need to replace this with f prime 3, and then we have x minus 3, f double prime 3 times x minus 3 squared, and then f triple prime 3 times x minus 3. Now, let's find the first derivative. The first derivative of the natural log of 4 minus x would be 1 over 4 minus x, and then we'd have a chain rule that would give us an extra negative 1. And when we put 3 in, we get negative 1 over 1, or negative 1. So our f prime of 3 right here is negative 1. So we have a negative x minus 3 as my first non-zero term. We need to now take the second derivative at 3. And so before we do that, we're going to rewrite this as negative 1, 4 minus x to the negative first power, so we can avoid the quotient rule. And when I derive this piece, I do get a 1 on the outside of 4 minus x to the negative 2, and then chain rule says multiply by negative again. So when I put a 3 in, I'm going to get another negative. So I get a negative 1 for the second derivative. So I have a minus, right? So for this piece right here, I just found it to be a negative 1 again. So I have a negative x minus 3 squared over 2. Now we got to take the third derivative, and so I bring down my negative 2, multiply by negative 1 and get a 2. 4 minus x raised to the negative 3, multiply by a negative again because of the chain rule. And when I put 3 in again, I get 1 to negative 3, which is 1, and therefore I get a negative 2 as my third derivative. So this value here is negative 2. But we're taking negative 2 and we're dividing by 3 factorial, which is just a 6. So we have negative 2 over 6. So we do have a reduction here. It becomes a negative x minus 3 to the third power, and then simply dividing by 3 because my 2 6 reduces.